Hey everyone, and welcome. This is Jake Caban-Tomski, and today I'm going to be talking about BLS Wallet, which is a Layer 2 smart contract wallet that includes a novel way of aggregating transactions. Let's go ahead and dive in. For the BLS Wallet team, you have myself up there in the top left corner, Jake. We also have our team lead, James Zaki, and we have two other developers, Katuk and Andrew, working on the project as well. Before we go too far into the what and how of what BLS Wallet is, let's go into why we are doing this project. So, as everyone knows, gas costs are currently, can be historically a problem on the normal L1 chains and even potentially sometimes on rollups, making it so that certain kind of decentralized apps or other opportunities or protocols or things people want to do become more difficult to do with those higher transaction costs. Users tend to have a poor experience when they're attempting to interact with those dApps when there are those higher transaction costs versus using something like a rollup where you're going to have the kind of the faster transactions and the lower transaction costs, which makes the usability of a lot of more decentralized apps possible. And so we're kind of in a world right now where there have been proven out some really good solutions for kind of people doing high value asset transfers, people doing kind of larger DeFi apps, or things involving kind of, big ticket NFTs with those higher transaction costs. As we move more into rollups and other like layer twos, we've been seeing the ability of certain casual games and some other applications kind of to open up within that. But we think that by getting those transaction costs even lower, we can do even better. And so using those EVM rollups and BLS signatures, which we'll go into a little bit more later, we think that we can open up things such as microfinance for developing economies and potentially even dApps that we have never seen before and potentially other applications by having those very, very low transaction costs. There's a significant portion of the world that lives on dollars a day, and so the kind of gold standard we would love to hit in the future would be something like a penny or less per transaction. And by being able to kind of reach that goal, it just opens up a whole world of different things we can all build. So let's go into what BLS Wallet is and some of the kind of technology underpinning all of it. It is cheap contract interaction at the end of the day. These are numbers taken from April of 2022 from L2fees.info. And as you can see here, in kind of this first column is the cost of sending a single token on these different networks, with the Arbitrum and Optimism being layer 2 rollups being significantly cheaper than the Ethereum L1 for this. And we have been able to get that cost even lower using a compressed BLS transaction bundle, reducing that by almost down to 25% of what the original cost is. We'll go into some more details on the gas for that and how that happened in a bit. And in addition, because BLS Wallet is a layer 2 smart contract wallet, we have this novel BLS signature scheme. We have the ability to do gasless transactions using that. We have all the standard account recovery functionality that you'd expect from a smart contract wallet. It can be upgraded to have new functionality. And these BLS bundles allow us to do multi-action transactions, which we'll demonstrate later in a little demo. And these are all things that are mentioned by Vitalik in EIP 4337, which goes into kind of account abstraction. So, where did BLS Wallet come from? Well, as with many other projects, we are standing on the shoulder of giants and a lot of previous work that others at the Privacy and Scaling Explorations Group have done to allow us to build this very cool wallet. To start, we have BLS signatures, which are Bon Lin Sachem, and I probably butchered that last one. Signatures, which is a pairing cryptography-based signature scheme that was done in first illustrated in 2002. It is actually used for the Ethereum Phase 0 deposits, the beacon chain, and a number of other projects. For specific details, the post-merge consensus layer is using a newer BLS 12 381 curve for that consensus layer. And currently on the execution layer, what we are using is the BN 254 curve, which we are able to use thanks to EIP 197, which includes a comparing cryptography precompile located at address 0x8. And so these signatures have a number of cool things for them, one of which being deterministic output for a signature given the same message and public key. But what we actually really like and want to take advantage of is going to be signature aggregation. So why we want to use this signature aggregation is normally when you write transactions to an L2, you have to include all of the ECDSA signatures for each of those transactions in the actual rollup data you push to that L1. If we were able to somehow reduce that, we could save on the actual overhead and space. And then using something like multi-call as far as the kind of transaction bundling does not really allow us to reach the scale or thresholds we want to for a kind of multi-wallet public key batching to try and drive those transaction costs even lower. So with that, what does this BLS signature aggregation kind of look like at a high level? Well, this is kind of a very naive thing, but you can think of each of these shapes as being a separate transaction, and then the kind of envelope around them being the signature for that transaction. And so what you're able to actually do with these BLS signature aggregations is you can take many different signed messages and merge the signatures into one signature covering all of those transactions. But that signature just takes up the same space as a single signature does. So you're essentially compressing that signature while not still being able to keep all of the verification for that and who signed it in place. What this looks like in a bit more advanced practice, which this article on cryptology I would highly recommend if you want kind of a good high-level overview of how those BLS signatures work, it's like this, where essentially those that compressed signature, as you see on the right, is made for all of these different messages and signed. They are all hashed into the kind of pairing-friendly domain that we need to have for verifying. And then finally, we check to make sure when we are verifying a given public key against those compressed messages that all that comes out valid. And so we're able to essentially have these large bundles of messages, or in our case, transactions, that we can verify using that compressed signature and then the public keys for each of those smart contract wallets. So the start of this project actually started with another project called the Hubble Project, which was a PSE, layer 2, which was focused specifically on very, very cheap ERC20 token transfers. And so those would all be done off L1 and done in a dual Merkle tree system, which maintained both the kind of account keys and the signature and the balances for the tokens in these two Merkle trees. But this system did not have any general EVM compatibility, so it was only able to do very specific things with kind of token transfers, deposits, and withdrawals. But the BLS technology that was used in there, which allows for verifying BLS signatures on chain as part of the rollback mechanism for that Hubble optimistic rollup, gives us actually the BLS signature libraries and for signing and for verification that we use in the BLS wallet project today. And so we spun up BLS Wallet, or rather James did, in late 21 as kind of a way that we could take this Hubble BLS kind of tech that's usable in the EVM and have it work just for any EVM general transactions. And so what this project contains and involves are a number of core kind of components, which include the smart contracts for the smart contract wallet and the signature verification for those transaction bundles, a aggregation server which runs on top of an L2 and will take these BLS signed transactions and merge them all together so that we can kind of reduce the amount of transactions we're submitting to that L2, a client module you can use to integrate with those two components, the smart contracts and aggregation service, and a prototype browser extension called Quill, which allows you to kind of try this out and use this in a standard Ethereum dApp, which we'll go into a quick demo of later. So when we have less L2 transaction data, we save on L1 gas. And so once again, the main ways to emphasize we're doing this is we're taking all of those different signatures per transaction and aggregating them into one. And then we also can do some things with some more common use cases, like say a token airdrop, to try to do some additional transaction data compression to save on what is being kind of rolled up into L1 from that layer 2 rollup. So to dive into some of those gas savings we kind of saw earlier with the token transfer, this test doc goes specifically over a test run we did on the Arbitrum testnet, going over the gas costs with basically just sending a token transfer normally versus doing a deduped 31 token transfer using our expander kind of contract to reduce that transaction data, and what the actual costs were and all these the different layers there with the compressed signatures. This top row here is going to be all of the BLS stats, and the bottom one's going to be the normal ones just for the normal token transfers. There are a couple of interesting things to note here as to why the costs are different. So you can see for BLS we're using less call data in terms of the units used. You can see here that we're actually using more computation units than the normal one would use. This is not as big of an issue as it would be on L1 because the computation costs on most L2s and rollups is very cheap because the entire network does not need to execute all of those all the time. And so the computation gas is generally much, much cheaper than it would be. And you can see here over on the L2 computation cost that is higher than for that transfer. Where we actually, and then you can also see here there's one storage unit used. This is most likely from the nonce in the smart contract wallet being increased to show that that transaction happened and increment the nonce to prevent replay attacks. You can look here for the call data cost, though, is significantly different. So those BLS transactions take up much less call data than a normal transaction would, and that is due to that signature aggregation and also due to just having less, or having all those transactions aggregated together into one versus having them as being separate ones. We went over that storage cost here, so just minor increment from that. What we get at the end, though, is the difference between doing those 31 transfers individually and just doing that one BLS kind of bundle in that expander contract is 25% roughly reduction in gas costs. So that's pretty nice to be able to save on that versus doing all those separately and not having that signature compressed. So as we can kind of see here, a lot of gas savings being able to use this kind of BLS transaction format and that aggregation without too much cost overhead from the smart contract wallet. So for how this is configured today, there's kind of a couple different layers of our stack that can be brought in. We have our extension prototype, which consumes our client module, which it uses to talk to the browser dApp, as well as talk to our backend aggregator service. That aggregator talks to a L2 node and submits all of those bundled transactions. Then, inside of the actual EVM, we have a thing we call the verification gateway that processes all of those BLS assigned transactions and then executes them once they're verified against those smart contract BLS wallets at the very end to actually run those transactions. As far as scaling, how these integrations kind of work out a bit more in depth is we have that dApp, and it's going to create a operation which has one or more actions inside of it. You can think of each of these actions as actually being a separate transaction, and we'll go into a bit more detail on what that data looks like inside of there. Once the dApp has what it wants to do there, it can send that to the actual wallet extension, which has that client module inside, and that will take care of the actual signing of those different operations that need to be sent out. Those are then submitted to our server or server for the actual aggregation and compression of those different operations into a single bundle of operations with the aggregated signature. One thing to note that's kind of important here is that these signed operations do not have to be from the same kind of person or wallet. They can all be separate and from different people. So I could actually have, say, 10 different BLS wallets from different people all submitting their transactions to this aggregation point and having them all merged into one single bundle that will execute for all of those people. So then, once we have that aggregated bundle of operations, that's when we actually submit it into the L2 EVM or into that rollup or layer 2 system. One thing that can happen is expansion, where we have, for that example, that airdrop, where there's some common things people might want to do to save a little bit more on that gas cost with that data compression. But then we dive into the core of the BLS wallet system. And so for that, there's the actual signature verification that happens on each of those operations and the actions within. And once those are signed, we then perform that operation through that BLS contract wallet, which is going to actually call the underlying transaction here once that's completed. And so through that, we're able to take this one kind of bundled operation of operations, do one L2 transaction, but then execute many different kind of contract interactions through those smart contract wallets here in the EVM. So for the next part of this, we're going to actually see in action with a quick demo we're going to do using Katuk's demo app he made. There's also another one Andrew made that you can look at below, involving kind of a billboard rent. And you can see kind of a more detailed in-action demo of all of this at that backup link below. All right, so let's go ahead and go over a full stack demo of the BLS wallet and how it works. As I said, we're using this ERC20 demo app here to kind of show that off. Up here, you can see I have the Quill browser extension installed here, which comes with a nice little kind of basic built-in page where we can see all of our different wallets here and some other kind of details and settings. We won't go into that in depth, but mainly to know I just have a wallet here at this address. Once again, going back into here, I would connect just like I would with any other kind of dApp. Right now, the wallet prototype will just kind of auto accept and do everything that it is told to do. So you won't have any sort of select accounts or confirmation that you want to connect. We plan in the future on adding that in to make it a little bit more like an existing kind of extension-based wallet. So there's my account connected in. And so as you can see here, I've already kind of done some stuff in the past. In the background behind all of this, in addition to having the kind of extension and the wallet running, we also have, one moment, two main things that we'll come back to and look at. One is we have this aggregator service. This is the one that is taking these transaction bundles from the wallet and is merging them together and submitting them into that L2, and then simulating kind of our layer 2 here. We just have a normal hard hat node, which will go through some of the contract calls kind of as we run these transactions. And so to start, let's just do a very simple one, which is just mint some more tokens. So we'll go ahead and click that here. If we look in the background as to what is being submitted in, we can kind of see up here in the ETH send transaction right here, there was that token mint that I sent. And that's just using the standard RPC call formats we have there. Here you can see it looking for that bundle, and it eventually will find it when it gets that bundle receipt. And if we go back into the app, by now we should have seen, oops, pardon me. Yep, that token balance increase. So we ran through that. On the back end, what actually has happened with that is we have the actual bundle added here. And then we're going to have down here the actual submission attempt to actually submit that as that L2 transaction there. And then once that is confirmed, we get that message out there. And then we can see here actually querying for the receipt of that bundle being completed. Up here in the actual logs, we can see some communication going on with the verification gateway, which we talked about earlier as being that kind of BLS signing gateway to get some details. This aggregator utilities perform sequence is actually this aggregator here checking to make sure that that bundle it received will actually work. And most importantly, right now this aggregator is running in a mode where it is free to be able to send transactions into. In more normal kind of mainnet production situations, we would expect that it would want to be paid a fee in order to run those transactions. And so this perform sequence check actually will make sure that the aggregator instance is paid when it after or simulate it running a transaction, see that it will succeed and that it is paid after that transaction is complete to make sure that it actually wants to run it. And then finally, we have the call to the verification gateway process bundle. And that is what's taking that actual bundle and submitting it to the individual BLS wallets for them to actually execute the calls in the underlying transaction. And here we can see we just made one call out to mint those tokens. Very cool. So that kind of shows a very simple example, but the more interesting one we can get into is where you actually have multiple actions happen at once, which we have with this bundle up down here. Unfortunately, the pull portion of it is not working for this demo, so we're just going to go ahead and do the bundled mint and approve instead and just have those two kind of things function. So to see what this actually looks like under the covers, if we go to the code for this, we kind of do the same thing we would normally do for any Ethers ERC20 or transaction, but instead of actually running the transaction, we're going to just do a populate. Then in the actual window.ethereum call to send, instead of just sending one transaction through, we're actually going to send two in an array. And what the extension will do under the covers is take both of those and convert them into that bundle format for use for submitting to that aggregator back there. So let's go ahead and run that real quick. We can see here in the background that when we submit that transaction, it actually contains both of those transactions with their tune from and data inside of here that we're going into. So in that way, you can essentially have a multi-action occur where only one transaction is going to go out. And sure enough, the token balance has increased. And if we go back into, once again, our aggregator and that command line, we can see that we had the bundle added. Make sure that's not the original one. It sure is not. We were waiting a little bit and we're checking for that bundle receipt. And then finally, we're submitting that on chain. When we actually go on chain though, so we can see once again, there is that kind of perform sequence to check the bundle there. We process that bundle, but then you can see there are multiple eth calls that are going out for that call because we are processing more than one in that single bundle. Once again, out to that ERC20 contract for the mint and approve. So that is kind of showing what you can do with just, even though this is only one transaction on chain, there is still a bunch of, you can still do multiple calls and multiple actions outside of that. Cool. And with that, we'll go ahead and go back and talk some more about why you might want to use BLS Wallet. Oh, sorry, we're going to go into some more details about how to use the BLS Wallet client module, and then some cases why you might want to use this in your dApp wallet or other application. All right, so we've just seen the kind of BLS Wallet used in the browser. So let's talk about how you can actually use this code inside of your own project. The main thing we have is a NPM module called BLS Wallet Clients, which kind of abstracts and takes care of a number of operations involving interacting with that smart contract wallet and with the aggregator service. So in this example, we are essentially connecting to our wallets. We're going to create a bundle. You can aggregate multiple bundles together if you need to on the client side or in another instance, and then you're going to send to the aggregator for that. So it's pretty easy to set up. Oh. And so once again, just kind of reiterate, connect to that wallet, create and sign a bundle of operations. You can optionally aggregate them together, and then we're going to send those to an aggregator instance. So kind of pretty easy to get up and running there using that client. Then let's dive into the actual bundle format and what it looks like. And it's going to look very similar in the actual structures that you would have in Solidity as well for how it's represented in the EVM. So we create a bundle, we call into our wallet instance, and we call sign. We provide a nonce for the bundle, which normally we just grab that from the wallet itself. And then we're going to provide a number of actions in order to kind of execute as part of that bundle. One thing to note is that in a bundle, all of these separate operations can, a operation in a bundle can fail, and the rest of the operations will succeed. However, inside of the actual bundle, anything that's part of this actions are going to be atomic. So if one fails, all of them fail, which can be really useful when you're trying to kind of figure out how you want to execute different transactions. So for example, one reason you might want to do multiple bundles from a single client is you're okay with one operation failing, but you want another one to kind of be separate from that. So in that action, we provide the ETH value we're going to include for that transaction, the address we're going to hit, and then the actual encoded function of what we want to do. In this case, this is an example kind of using a ERC20 contract to approve and swap in a single transaction. And so here we have the actual encoded approve function for that ERC20 for the DEX contract. And then here's the actual swap running inside of just that one single bundle. So why should you use BLS Wallet? So we've kind of gone over what it looks like when it's used, some high-level stuff about the project, and then how you could consume it in kind of JavaScript, TypeScript in your own application. But there are kind of three main use cases we see for where people could take advantage of BLS Wallet to save on those transaction gas costs, as well as get some other nice features that you get with a smart contract wallet. For decentralized apps and kind of wallets with BLS Wallet in them, the biggest thing you're going to get is that multi-action support. So anytime you have kind of users that have to go through and perform multiple transactions or kind of multiple actions within your kind of dApp, instead of having to do those all separately, you can simply just stack them all up and do them all at once. In addition, there are ways that you can, using this kind of BLS Wallet framework, do cheap or even gasless transactions. So one way, as we kind of showed that aggregator, you can subsidize at that layer using, we have a package called BLS Wallet Aggregator Proxy that allows you to wrap an existing aggregator that perhaps takes payment and modify kind of the bundles people are sending in to add in transactions that would pay that aggregator. You could also do it even at the contract level where, say, you have an additional wrapper under contract, which will pay your aggregator instance or another aggregator instance whenever someone runs a transaction on that. So by doing this, you can essentially, and you might be able to add people in for this using some sort of thing like an allow list. You might allow only a certain number of transactions to start are paid for by you. And so in this way, you can kind of people come in and use your dApp or your wallet without ever having to buy Ethereum initially and transfer it in to that wallet. And that also can help incentivize people to kind of just come in and try your app with very little risk as far as the payment goes. And one reason you might want to use BLS Wallet instead of a normal, say, gas relayer is that by using that bundling and that kind of BLS signature scheme, you're going to be saving on the gas costs. So if you do end up subsidizing those transactions, they will be cheaper than they would if you were subsidizing them via a normal gas relayer. Another cool thing with the more smart contract wallet aspect of it is it's an embeddable smart wallet. So you could see a situation where you could actually set up inside of the browser in your dApp a wallet that runs for that user just kind of right in there. They don't even know that they're using it. There's no need to have a kind of QR code to connect someone's mobile wallet or to install an extension for them to have. And as I mentioned, kind of you may not need that for them to fund it as well. Then later, if someone wants to move to a more secure wallet, they can eject by swapping out the BLS public key that is on that smart contract wallet to kind of have another account or device take that over if they want to with that. And then finally, along with all that, you get kind of some of the standard account recovery and upgradability for that wallet as well. So if someone wants to switch to a different, better signature scheme in the future, or if someone wants to upgrade their smart contract wallet to just have some additional kind of functionality or security, they can do that later via that kind of those upgrade paths for that smart contract wallet. If you are a layer 2 node, you may want to incorporate kind of features more on the aggregator side from BLS Wallet to help make your layer 2 network better. This main one for this is mainly just reducing your gas costs on your EVM L2 by having those bundled transactions and by helping to get rid of a lot of that signature overhead in the data you have to roll back to L1. And you get a nice little rank up on L2fees.info. It can be beating all the other networks. In addition, because we are taking multiple transactions and merging them into one, that's going to be able to help reduce congestion if you're getting a lot of kind of traffic on that network via bundling. As we've seen kind of with the recent Arbitrum Odyssey NFT giveaway by people using the network, they ended up having to postpone that until they made some other updates to their network to handle the high fees for normal usage that were happening due to people participating in the Arbitrum Odyssey giveaway. There may have been a little bit less of that if they'd been able to do this bundled transaction format. And then finally, by incorporating kind of BLS Wallet in, you can encourage the adoption of dApps and wallets, which have chosen to adopt BLS Wallet for use there. And they can just come in and instead of just using an aggregator instance, they can just directly submit to your layer 2 node versus having to go through kind of more middlemen in that process. So in the future, we expect that the configuration options for this will actually change. As I mentioned, for that kind of L2 node setup, instead of having an aggregator and an L2 node running separately, we would have just all of that be running inside of a standard L2 node that could bundle and all those together. In addition, right now we're just focused mainly on that browser use case, but there's no reason why a mobile wallet would not be able to use that same smart contract wallet kind of interface to construct BLS bundles and transactions. And then finally, right now we have our own kind of smart contract wallets, but we expect that other third-party kind of contract wallets, such as Argent or Gnosis Safe, would be able to use this novel kind of BLS bundle transaction scheme for their own transactions with that wallet, using this BLS verification gateway to sign those to verify the signature on those transactions, but then execute them through those other smart contract wallets. And so those are kind of where we see things in the future going as far as how they could be configured. As far as next steps, kind of following up on everything we've covered, we have created an organization called Web3 Well, where we're trying to get features built that wallets, dApps, and L2 nodes could adopt to kind of help make the ecosystem a better place. Right now, we're starting with just this BLS wallet project, some improved kind of dev and integration docs, trying to have good defined issues in the repo. And also as part of that, we may end up having some dedicated devs making PRs into different wallet or client repos to try to kind of like bootstrap getting that BLS wallet work in. And then the last part, of course, is adopting and upgrading to standards as they solidify, such as the account abstraction in EIP 4337, and then through groups such as the Ethereum Wallets group, where there's been some work going into better ways that browsers can interact with wallets, and dApps can kind of figure out different features that are available to them through those wallets. And so we're hoping to kind of help push some of that work forward with this Web3 Well integration initiative. So come quench your thirst from the Web3 Well. That link on the left is going to be our Discord server, where we kind of talk about some of this stuff, specifically BLS Wallet at the moment. And then finally, you can find the BLS Wallet GitHub project at github.com/web3well/BLS-wallet. Please come by and check out the documentation and everything for that as well. And with that, we will do questions. If you have a question and you want to submit somewhere, on the Privacy and Scaling Exploration Discord server, there's the Got a Question channel. And then if you did join via that previous link on the left there, the Web3 Well Discord, for BLS Wallet specific questions, we have a channel called BLS Signature Comp, where you can get those answered. Well, thank you so much for stopping by and listening to this presentation.